Hello, everyone. Thank you for joining us today for our exciting webinar where we're going to talk oil well drilling optimization. Today, we are going to kind of do a deep dive in some edge AI and IoT. I'm going to provide just a few more minutes for folks as they come in, but we will get fired off here in just a second. So please bear with us as we get all set up. Thank you.
Hello?
Hey, Sebastian, great.
Hey, sorry about that, guys. Just logging in.
No problem. So yes, so we are live and recording. We're just waiting for folks to all get in and get settled. We have a number of folks already in attendance, and we are going to start here in 1 minute.
Okay, great.
Okay, all right, well, why don't we jump in today? This is a recorded session, so we will be making this available to anyone out there who might find this interesting. Obviously, we're going to do a really deep dive today and dive into what are technology concepts, IoT, edge, and artificial intelligence, machine learning. We're going to talk those concepts, but we're not going to just wave our hands. We're actually going to get really deep into the business concepts, specifically oil well drilling and optimizing the drilling process. My name is Aaron Alsbrook. I'm the CTO and co-founder here at Clearblade. So I've spent a lot of time in our IoT and edge offerings. And I'm joined today by Sebastian Maurice. He's the Audix CTO. And boy, does he have a depth and knowledge in this topic that's impressive. I'm going to do my best to hang with him today as he shares some real detail about how do we understand the data that's coming out of a drill. It certainly sounds simple when you think about it, but talk about a scientific domain and a real business knowledge. Sebastian, would you like to say hello real fast?
Yeah, thanks, Aaron. Sebastian Maurice, I'm the founder and CTO of Audix.
Yep, and so what we'll do today is we'll very quickly be patient with us. We'll do a little bit about our companies just so you understand where we're coming from and why we belong and why what we're saying matters a little bit. Then we'll go in and actually talk through how do these pieces of technology work in concept. And then after that, we'll actually get really into the weeds. We'll show you what's going on. We'll give you a demonstration of what's happening and really talk about some of the dependent and independent variables ultimately to make predictions. All of that is a bunch of noise if we don't get to the end, which is what do these predictions mean for our business, and we'll show you the ROI. So with that, let's dive in. The first thing to know is, what is Clearblade? Why are we talking to you today? Well, Clearblade is industrial software. It's software for enterprises to use to do IoT and to do edge computing. Again, we actually are focused on serving enterprise needs, which means we're not going to force you on a cloud of our choice. We're going to run on whatever cloud you want to run on. We're not going to force you to run in the cloud. You want to run on premise. You want the security associated with that. Yes, we support that. And also, we're going to run our full platform capability, not just inside of a cloud-friendly environment with some dependencies on the cloud, but we'll actually run it all the way down at what's called the edge. The edge is that remote computing. So when you look at all that, that means we're going to run any cloud, any server, any gateway. And then from there, we'll talk over whatever protocols you need to talk over for how you'd like to get the data back. We'll run over different networks, private networks, public cellular, private cellular, LTE, ultimately to talk to wherever the device or the machine is. So any is a big part of our offering for doing IoT and edge software for enterprises. Sebastian, quickly introduce us to Audix.
Yep, thanks, Aaron. So Audix is an AI solutions company. We provide end-to-end solutions for your data, and this data could be resident or just resident data or data streams. Audix, we feel that we are one of the few companies today that can really deploy AI solutions faster than really a lot of vendors out there today. But of course, another part of our company is services. So we also provide data science services that allows really to us to deeply understand the data, understand your business problem and your business domain to come up with a really effective solution that provides outcomes really quickly. Our products are focused on really automating the machine learning process. So MADS is one of our core products. Then Viper, which is, as I mentioned, is a data stream connector. So connecting to how your data streams in real time and continuous flows of data to provide machine learning on top of that. And then what we will introduce, what Aaron will talk about is transactional machine learning is, well, how do you do machine learning on real-time data or IoT data that we'll talk about? And that's a really new, exciting area that Audix, together with our partners from Clearblade, are really expanding and opening up in the industry today.
Yeah, and why this is so great is the problems we're engaging with are interesting and difficult in a lot of ways, right? It takes partnerships like what we're doing here today for us to bring all the domain experience, all of the right technologies to solve very specific issues. So very pleased and very excited about this partnership with Audix. Obviously, we officially announced it last week over some really cool stuff we're already doing together and how we've integrated these two product sets, this AI technology with this IoT and edge technology. So real fast, and again, Sebastian, please chime in as things come to mind here, because I want this to be we really want to share here with our audience, but ultimately, let's start with the idea of, what is actually happening with the underlying technology? How are we wiring these pieces together to put this story in place? So we'll start at what is today. Today, machines and equipment sit out. They sit out at the well, the drilling location, and they're generating data. Hot data is a fun word to describe this. This is the information that's coming off. It's streaming. A lot of this information, if we were to think of it like they call data is the new oil, this data just spills to the ground and washes away. We're never gathering or never doing anything with it. It's legacy protocols, Modbus, SNMP, SCADA, however this data is coming off, it's there. It's in the moment for the workers and stuff out in the field, but it's trapped. Edge comes along, and Edge allows us to tie this information. We're able to pull it off however it comes at us, whatever organization, we can put it into a structure we understand, and then we can do that at the edge, process it, and even apply rules, trim down the information. We might have gotten 2 gigabytes of logs. All we really care about is one particular alert in there. Trim it out, get the data we want, understand that when this pressure is at this bit, we'll have hard and fast rules for saying if the temperature is above, turn off. That sort of stuff happens at the edge. There is some information that's invaluable if we can send it up to the cloud, where we begin to build and aggregate that data, or to the back office as well. That back office IT cloud data center, wherever it is, we enrich it with lots of data from lots of machines, lots of equipment. And that's where we watch the magic happen of artificial intelligence. We build that model, we take that model, we get a good understanding. Again, you would imagine there's this whole life cycle of, are we validating the quality, hitting the thresholds we want? But once we understand it, then we're able to take that model, that AI algorithm that understands our business, and bring it right back out into the field, right back at that edge location, and then begin to use it. So now our rules are not just if temperature greater than, our rules become more of a transactional machine learning. Each time we get more information, we make a prediction, and it's instead of just the hard and fast rules, it's the prediction that's driving us. This is of huge value because each model that sits down here at the edge becomes unique. One of the challenges that Sebastian and I often talk about is the fact that there isn't just one AI model. There's, I mean, what was your latest example? 7,000 models, one for
Yeah.
each location, right?
And so that's really where that challenge is. And, we talked about, one model or two models or three models. I mean, that's the easy stuff, right? Where it gets really difficult is when you start to scale. And what we'll show you is, what if you have, maybe 1,000, 10,000 IoT devices all streaming data at the same time? How do you then make sense of all that data? So really where this kind of, makes sense within an IoT framework is scalability and how we apply machine learning to large scale situations that we will show you today. And of course, oil and gas and energy are perfect examples of hard devices, metal devices with sensors attached to them, all generating a lot of data. And how do you manage all that from an end-to-end perspective?
You got it. So let's dive in. That's a good setup into let's actually dive into the real use case here, and we're going to kind of to so to speak geek out on the actual problem. When you're doing AI or really anything where you're trying to do IoT, you start with the idea that you're going to have some independent variables. This is the state of what's actually happening at this location, right? You could imagine that if we were talking in this case, the soil structure, the type of composite we might be going through, honestly, the brand of drill bit that we might be using. These are all independent variables that exist out in the field where we're doing the drilling. So from the left-hand side, we have some independent variables that are pretty much static: temperature in the air, how frozen the ground might be. But then we're also brought in other variables that we might be able to control. Again, they're still dependent on independent on how we want to do with them, but they're ultimately what sort of pressure are we going to put on that drill? What kind of torque are we going to use? How many RPMs are we going to drill with? What are we going to do in the conditions? All of that is essentially input to us. It's input that allows us to basically understand what is going on at the drill site. What we're trying to do is we ultimately want to make decisions about that drill to improve outcomes. At the highest level, we want to reduce the drilling cost. That means we need to save energy. How much energy do we put into the drill? If you think about it, the drilling process takes fuel. Fuel is spent drilling. We want to reduce that. It takes man hours, salaries, people out there. We want to reduce that. So we want to drill as fast as possible with as least energy as possible, but while also maintaining other safety sorts of mechanisms and protecting our equipment. We'll certainly hear and find that in lots of cases, we will drill in such a way that we cause premature failures. We'll break our bits. This requires a large, expensive process. So when you think about, we have these inputs, these variables, we want these outcomes. What are the predictions that we can make with that data that helps us drive towards better outcomes? And that's where that middle column is so important. We need to be able to predict the hook load, the weight on bit. That drives us to an understanding of rate of penetration. How quickly are we driving into the ground? And all of that leads to a very nice simple number of what was that specific energy, that mechanical specific energy it took to do that drill.
Yeah, I mean, if I could just add a little bit here, Aaron. So that middle column, that's really decisions, right? Decisions that humans and machines need to make. But really to make that decision, a good decision, you need the variables. So think about the variables are sort of these influencing factors for you to make a really good decision, i.e., what is the optimal amount of hook load? What is the optimal amount of weight on bit? What is the optimal amount of rate of penetration? For a human to do that, it's going to take you a lot of time and a lot of energy to make those human-driven decisions. That's why we use data. That's why we make data-driven decisions, so we can actually reduce the friction caused by humans when it comes to these machine learning processes. So reducing the friction is a really, really important aspect for the outcomes, i.e. reducing the cost, reducing the energy use, improving worker safety, and drilling faster. Right? So we can take those human touch points and reduce the human touch points. We're really reducing the friction in conventional machine learning processes. We're making it more smoother with what we're proposing here with our technology.
Yep, perfect. Well said. Thank you, Sebastian. I told you guys he was the right man to explain how this all comes together. It certainly is an interesting when you look at how we have to bring these different domain knowledges and bring them into context of things like AI and IoT. So with that, why don't we dive into a little bit of a live demonstration so we can show you what this looks like working in a simulated environment. Hopefully you all are seeing what is our dashboard for drilling optimization and service management. Sebastian, again, please feel free to help make sure we show the right drive into the right value proposition. But ultimately what we want to do is we want to be able to look across what is a number of rigs that have multiple wells. We have a dashboard that shows us at a top level what are some macro events that might be going on, things in other systems that might be affecting our rigs. You can see here that we have no events showing up, but these are most important. You'll notice we also provide the ability to create incidents. We recognize these technologies don't live in stovepipes of technology or silos of technology. This incident is a direct integration into a third-party system for managing field service working, so that we're not necessarily isolated. We're sharing data between systems right out of the gate, top level center. But then we can see that data, those independent and dependent variables are sitting right here across all of our wells. And we can look across these and see this information in real time. If I refresh this, there probably is a live feed that should be running here for us to enjoy. So I'm just going to reload it one more time if you'll bear with me.
So as you're doing that, Aaron, so let me just set context here. So what are we doing? What problem are we solving? So as Aaron mentioned with the variables and the predictions of hook load and weight on bit, as a driller, if you're drilling a hole in the ground, right, using a drill bit, you want to know what is the optimal amount of weight I need to put on that drill bit, right? Because if you put too much weight on the drill bit, you're likely going to reduce the run life of that drill bit, i.e. the teeth on those drill bits are going to dull out really quickly, and that's going to cost you a lot of money to replace the drill bit. So wouldn't it be great to actually tell a driller what is the optimal weight that you need to put on that drill bit so you can extend the life of the drill bit, use it for a longer period of time, and save less money? And that's what you're actually seeing in this table here. So you're seeing the rigs, the wells. The ARAD is the automated rig activity detection. These are basically states that a drilling rig goes through. When you turn the rig on, that's a state of turning it on. When you're drilling, well, that's a state of drilling. When you're back reaming, that's a state of back reaming, et cetera, et cetera. The other column that you see here are pipe grades. So we looked at 6 different pipe grades in a drilling process. Pipes have different grades, and those grades are really the tensile capacity or the strength of the pipe. So if you're drilling in a very hard rocky surface, you likely will need a different pipe grades that has a very high tensile capacity, meaning, which is actually the 4th column there, tensile capacity, which is basically how many thousands of pounds can you actually put on that drill pipe before you break it, right? So that's that. We also looked at different bit sizes. In the industry, the bit sizes in inches is about 8.625 inch bit, and a larger drill bit, which is a 14.75 inch drill bit. Now, why are we using that? Well, the size of the drill bit really impacts how much weight you can put on that drill bit. That weight will vary given the size of the drill bit. Once we actually know the drill bit size, the tensile capacity, we can actually tell you when you're drilling a hole in the ground, whether you need to change the direction of that drill bit or you keep that same direction, right? So there's some business rules that we talked about that we can automatically, or that our solution can automatically tell you whether you're drilling straight or whether you need to change the direction of that drill bit so you avoid hitting a rock. If you hit a rock, you likely are going to break the drill bit, or you're going to get a pipe stuck, and those are two very expensive problems to fix. The bit weight alert, that basically tells you how much weight and what is the optimal weight you're putting on the drill bit. The overpull amount, that's the amount of pressure that you could put on the pipe. So let me kind of say it this way. If you're drilling and your pipe gets stuck, what is the natural response? Well, to pull it out of the ground. That's overpull, right? And so given the tensile capacities, the amount of pressure you can put on the pipe is really that overpull column, the optimal pressure you can put on it. If that overpull exceeds the pressure that you can put on the pipe, well, you're going to break the pipe. Right? So by really telling you, what is that optimal overpull, it's really critical so that the driller doesn't break his pipe, and then you can continue drilling, because pipe breakage is going to be very expensive to fix. Hook load prediction is our predictive model that's giving you that prediction. Now this is important. The hook load requires an individual machine learning model. All of those different numbers you're seeing there, those are individual machine learning models that we've built for each of the wells, right? So think about from a conventional sense, if a human were to do that, that's going to take a lot of time and effort. Why don't we just automate the build of those machine learning models? And those are the products that we talked about, MADS and Viper. That's what MADS does. It's automated or automatically builds these models for you, so a human does not need to do so, right? So we reduce the friction by removing the human touch point in the machine learning process. Once we have the hook load prediction, that actually feeds into a weight on bit prediction. So what are we doing here? Well, we're basically daisy chaining models, right? We have the first hook load prediction that we make. The output from the hook load prediction is an input in the weight on bit prediction model. So that's how we're able to daisy chain models. And think about, it's easy to do for 1 or 2 models, but we're doing it for 30 wells, 2 models. We're building 60 machine learning models in real time. That's the cool piece. And then we get into looking at your health risk prediction. So now we're seeing people wear Fitbits, things that can take your skin temperature, your heartbeat, etc. Well, we're building another machine learning model to predict how is your health. If you're a drilling operator trying to operate a rig and you're running a high fever, we can actually predict that that high fever is going to lead to a high health risk. So you probably should not be drilling a hole right now or using that equipment to drill a hole. So we can actually predict that, and your manager will of course take you out of that role. The weight on bit accuracy. So these are the accuracies for the model. So when you're actually predicting something, well, you don't know what's going to happen in real time, right? When that actually happens. So the accuracy tells you how good is your model in the prediction. That's the accuracy. And it compares the prediction with what actually happened with actual data to come up with that number. So actuals minus predictions divided by actuals gives you that percentage in the weight on bit accuracy column. And we also do that for the hook load accuracy as well. So you can see the accuracy is fairly high. Thanks, Aaron.
Yeah, no, this is great. So this is a great setup. And you look at this, all of this data is coming in to make these predictions. And then on the right-hand side, you actually see what optimizations. Again, we'll talk about how we can simulate and let people test and try some things out, the what if scenario. But ultimately, you can see that some optimizations are being made. And I find it fascinating in the data that's being presented right now is that we actually are slowing down our rate of penetration and putting in just a little more energy. So in some cases, it's not intuitive that just drilling faster might save us money. When we get into the financial details, we'll see that compelling reason why it matters to optimize this. It's not necessarily that we're trying to optimize one variable. We're trying to optimize them all together to save what is a final total cost of the drilling process.
And so really the relationship that you want there with the rate of penetration and with MSE is you want to drill faster, using the less amount of energy. So if we can actually get a driller to drill faster and use less energy, that's going to equate to more cost savings and more revenue. So we want to look for in this solution to increase ROP while reducing mechanical specific energy, which is required to drill a hole.
Mm-hmm. And so what we'll see on this dashboard, we look across all our rigs and have live data sitting here. Again, this is all information that's streaming directly from our rigs. If we're at the edge, you visualize only the rig you're at or only the well you're at. If you're in the back office, you have this information available to you from your cloud view, from your dashboard. As you would expect, we have the ability to navigate through and look at specific rigs, move to specific wells. Here you can see this rig, the operator that's interacting. Same set of variables here, but narrowed down for a specific well. What's interesting is if we drive all the way down into the well, we actually can see the weight on bit and hook load values over time. This is really, really compelling if you think about trying to understand what's happening at the overall well over the period of the course of the day. So we track this historically for you. And then we let you say, what if we change some of our variables, things that we do control that today we might want to do manually? What if we changed our torque, the pressure we were putting on there? What if we sped things up? We actually can run these tests and see what is the outcome. Each well has a different type of maximum, I call it the red line, of hook load and weight on bit. So you can run a test, a what if, with different variables that we as the wildcatter or the driller ourselves have the ability to control and see where we might redline that. Now, Sebastian, please feel free to chime in, but what we really want is we want the automated algorithm to make this decision for us, right? That's where we want this to go. But it's great to see that you can actually simulate changes that I might make.
So there's two ways that this solution differs from other rate of penetration solutions out. So this is, there are other solutions out there in the market. How do we differ? So Aaron just mentioned automated machine learning is one of the key ways that this solution differs from other ROP solutions in the market today. So this is really important. Why? Because as data is flowing from all these sensors that you're using in your drilling process, the underlying structure of that data will change over time. Conventional machine learning processes that require humans to build machine learning models cannot work as fast as the data is flowing in. So using auto machine learning techniques, we can actually trigger a retraining and a relearning of that new data that's flowing in real time without requiring any human touch point or intervention. Again, we talked about reducing the friction in the machine learning process. So that's really one differentiating way that this solution differs from all of the other RP solutions in the market today. The other way that this solution differs from other solutions in the market today is what if analysis. So what if, that's actually real-time what if analysis that allows business users, drilling operators to figure out, well, as Aaron was mentioning, what if I increase torque by plus or minus 10%, plus or minus 15%? What would the impact on weight on bit and rate of penetration be if I were to increase torque? If I were to increase pressure? What if the hole depth is changing? So of course, you're drilling a very deep hole. The parameters and the data that are going to come off those sensors are going to change. And as I mentioned, that underlying data generating process will change. So you would need to relearn what those changes are so you can come up with that optimal hook load, optimal weight on bit in real time, right? And those are the two critical ways that this particular solution is the only solution in the market today that can do that.
Well, I'll add to it. I think where we go here and what we learn from this is where it really differentiates, Sebastian. It's the idea that we didn't just, leave it there, right? We actually took it all the way to financial details. And this is pretty cool. So now what you see is we're looking across all of our wells, being able to look at the average rate of penetration, the average weight on bit before and after. So we get a very clear picture of what we changed thanks to this automated learning. We get a very clear picture of what our new mechanical specific energy is that we put into this. This is all great. We now understand drilling days. We reduced our drilling days. We've drilled the same amount of depth, but all of it comes down to cost savings. We're saving over $830,000 in risk avoidance. We're also saving in terms of reducing the overall cost of drilling the well. The fact that we take all that great stuff, ingesting all that IoT data, that edge processing, the AI models, the customization per well, it's all well and good, and it's very, very exciting, especially those in the technology space. But this is what justifies it. This is why we're here, and this is what we're trying to do, and we're putting it front and center with the cost savings.
And so what I wanted to kind of display here is, is the red and green arcs. So what are the red and green arcs? So the red arcs are arcs without our solution. So this is basically doing a before case. So exactly what it says, before and after. Before you use our solution, and the after case is after you use our solution. So this is actually very transparent. And what is the value of this solution to rate of penetration, WOB, and mechanical specific energy? So what we've also done is we've taken those top line numbers and we've actually related that to total drilling days. If you're a big company, you know, like a Neighbors Drilling Services, for example, what you want to do is as you're drilling these holes, you want to drill it as fast as possible. What if you can actually reduce the number of drilling days that it takes you to drill a well? And if you can, that's relating to about $200,000 to $300,000 of cost savings per day in drilling those holes. So using optimal rate of penetration, optimal weight on bit numbers, we can actually relate that to a reduction in drilling days. And that's the green piece that you see here. The total depth, we made it constant at, say, 17,900 feet, and that's simply for our calibration. And drilling cost is, of course, the overall cost that this solution can potentially save. And what we've done is we really want to show the driller in real time, as you're drilling a hole, how does all of this equate to my bottom line, right? Is it saving in money? Is this making money? And what we've also added here is, of course, risk avoidance. By allowing us to build these auto machine learning models with streaming data, what we're actually doing, and predictive analytics, what we're actually doing is reducing the risk from not using subjective decision making, but we're using objective data-driven decision makings that the machine is giving you. And that's where that risk avoidance comes from. And of course, if you fold all these things in, you get to the potential cost savings for each of the well of about $920,000 on average. So that's where all these numbers kind of make sense. And if this is running in real time, you actually see these numbers changing in real time as well.
Perfect. Let's look at a quick summary that you guys have pulled together. We pulled together here with regards to one particular use case. What you see here is real data that's come back. You can see actually the before settings, so what happened as the normal status quo of business, and then you see what we've been able to do by optimizing with these AI algorithms for each well. I won't read the numbers out, but what you see here is some pretty amazing specific, changes in the overall specific energy used. The cost per well to drill per day, $90,000. These numbers stand out very, very large to us because when you put it in context, just by bringing in this little bit of technology, we're saving $30 million on 30 wells. Anything to add there, Sebastian?
Yeah, you can see, I mean, these numbers on the change column there, the red numbers, minus 4.41%. I mean, they may seem small, right? But these marginal changes and these marginal reductions, when you actually scale it out to, hundreds and thousands of different wells, they actually roll up pretty quickly. And that's really the roll up number, $27 million across the 30 wells using this solution. Now you can argue, well, of course, this is going to change from well to well and from location to location, et cetera, et cetera. Yes, absolutely. But having a data-driven model like this or data-driven solution like this that automates that whole process gives you a better chance of saving money and a better chance of making money because we're using a data-driven decision. And to us, I think that's the smart way that drillers are going. And by the way, that's really where the industry is going, right? If you think about what the larger companies are doing using automated processes, in optimizing the drilling process, that's the future. However, what we need to do now is to add additional intelligence, deeper intelligence into these processes in real time. And that's where bringing data streams with auto machine learning, with IoT, is a really, really critical step forward for the industry.
So, one of the things we just talked about there is we talked about the drilling process. That is, basically drilling the hole itself. One of the things that you realize as you think about this is there are other activities that have to happen besides just putting torque on the drill bit and pushing it into the ground. There are processes that are called ultimately that are for cleaning the hole and having good health as we do the process. Two that we've talked about already is the clean process and the back ream process. When you're doing well drilling, you have to decide, as the operator, you have to decide, now's the time I should clean it, now's the time I should back ream it. And yet again, after we say, yes, now's the right time, we then have other parameters. Cleaning's pretty simple. If you've done that job, you understand it's basically how long should I do the cleaning activity. But if we talk about the back reaming, there's a number of configured parameters that have to happen. So what we've done here is we've not only thought about AI in the context of drilling and protecting our bit, but we've also thought about it in the context of maintenance of the overall drilling activity. Yet again, we have variables, inputs into the process, things that we've studied over time. A lot of the same variables we already talked about, the rate of penetration, how quickly we're moving through the ground, the type of soil we're in, that still exists, but we're gonna make different predictions. We're gonna decide to clean, not to clean, to ream, not to back ream. And then ultimately, it's not just those decisions, it's if we do those activities better, we reduce the flat time, the amount of time that people are standing around not drilling a well. So we're bringing up our utilization of our workers, we're getting better efficiency. Because we do this at the right time, we're gonna get a better quality well. So ultimately, these kind of ancillary activities to the well drilling process overall also impact what we're trying to do here. Sebastian, anything to add?
So you can see kind of the storyline here, right? I mean, these are problems, business problems that drillers deal with, and we've only shown you 2 or 3, core problems here. I mean, there are hundreds of problems in the drilling industry that machine learning, can solve. So very quickly, let me set context here. As you drill a hole, we talked about cleaning a hole. The mud builds up, right? So you're drilling a hole. There's a lot of mud and earth, being stirred up underneath the ground. What clean hole allows you to do is basically, or what our solution allows you to do is predict when you should start cleaning a hole, right? When you should start removing the mud that's surrounding your drill bit and your drill string, so you can actually, drill a deeper hole. So that's, when should I clean the hole? And as Aaron was mentioning, that's one decision, right? When should I clean it? So the machine is going to tell you, oh, I think it's the right time to clean the hole. Then the next question there is, okay, now that you've told me to clean the hole, how long do I need to take to clean the hole? And that could be, a couple of seconds or a minute or two. So now we can optimally tell you, you need to clean a hole, and this is how long you should take to clean the hole. Number 3 is back reaming. So back reaming is basically you're drilling a hole, you're making the sides of the earth in the hole, in the well, smoother. That's back reaming. So now the model can tell you, oh, I think you should back ream a hole. You should smooth out the sides of the earth. Now what we told you is when you tell me to back ream, now the solution will tell you also, or the driller, the human, wants to know, okay, now that I know when to back ream, what are the optimal dial settings that I need to set to back ream the hole? Because there are pressure settings, there are different types of settings that driller needs to go through are set to optimally back ream a hole. So rather than him or her subjectively making those decisions, we can objectively, using our solution, tell you these are the optimal dial settings to optimally back ream a hole.
And I love where you say the dial settings, right? Because if you think about where that leads to, right, that leads directly then that IoT integration and removing some of those settings, that human process in there, right? Automating that setting and setup. Let's take a look at what this looks like. Again, we put this directly into the same framework here, the same user interface now. Again, this is user interface that is integrated with the ticketing system. It is integrated with other systems, but now we've also brought on the idea that we can do predictions. We can actually come in here and begin simulating data streaming back and forth. And we see two basically green dots. It's time to clean. Now it's red. It's not time to back green. So we are able to generate those two predictions. Again, you see two predictions right here across the top, color coded. Below, you see what's going on where it's actually generating those settings. How long to clean? 17 seconds is the recommended time right now, 16. So again, we're simulating this data right now so you can see that ultimately we're going to kick back exactly what decisions should be made. The fact that this is all tied into the overall edge and IoT solution means we can actually automate these things to go ahead and force them to happen with these settings. So again, we gradually introduce this into overall process such that now we're making the correct or the ideal back green settings for how we make sure that that hole is smooth along the way. Anything you want to add here?
One important point is the threshold. So if you can just move up a little bit, Aaron, the threshold, yeah, perfect. So what are these thresholds, right? So think about this, right? When you're predicting something that has a probability, what is the probability that the weather tomorrow will be sunny, right? The weatherman will, weather person will tell you, oh, there's a 60% probability of sun, right? Or a 70% probability of rain. That's a threshold, right? In this sense. So we were to actually change the thresholds on, back reaming 46%. What that basically tells the algorithm is that tell me, or the human tells to tell the human when the probability of back reaming exceeds 46%, then trigger a back ream, right? Or for clean hole, when the threshold of clean hole exceeds 70% probability, then tell me to clean hole, right? Because if the threshold was 0, the model will be telling you to clean hole all the time. Well, that doesn't make any sense. So as we increase the probability, what you're really doing is increasing the accuracy of the model. You're basically telling the model, okay, I want you to tell me to clean hole and back ream a hole when you're really sure. So the higher those numbers, the more, I guess, surety or the more accuracy that the model will have before it tells the human that you should back ream or you should clean hole, right? So that's the changes in those dials. So the higher the number, the more sure you want the algorithm to be. The lower the number, you don't really care how accurate the model is.
Great. So with that, let's dive in one more time and just think about, what's important here. Obviously, the merging of these different technologies to get the data, to pull the data from the remote well location, the IoT information coming off of it, the ability to aggregate that data so that we can begin to create and define these models, the ability to move these models back down to the well so that we have them potentially in a disconnected state still available to our operators. But then we see the real need ultimately to manage this at scale. Again, we heard here that we had one well with two dependent models just for what the parameters were to drill with, and then we saw other models. So we end up with a real cascading count or exponential count of models. And so the governance around these models is important, how we store them and manage them, when do we put them into runtime, all of that's important. And again, I think Audix is got a great strategy here. Probably talk about this. Sebastian, tell us a little bit more about how you put this together with Ames.
So just a little bit of context here. So if you think about what we're doing, right? We're producing data and we're consuming the insights from the machine learning model. So producer consumer, and that's what you kind of see on the right-hand side, or right-hand side of the dashboard. You're seeing consumers, which are basically the dashboard. So the dashboard is a consumer. So what Clearblade is doing is basically consuming the insights from the machine learning model and visualizing it. Pretty simple, right? Now, those consumers, so for Clearblade to actually consume the data, it actually needs to know the machine learning algorithm. Okay, what algorithm do I use to extract the insights so that I can visualize it, graph it? those are the consumer algorithms that you see in that top, right? The producers is, of course, Clearblade is ingesting data from IoT devices and sensors and producing it into a database or an IoT stream, data stream. So that's the producer of it. Now, the middle piece is Audix, right? Audix is then taking all that data that's been produced into the stream and creating all these machine learning algorithms. Now, there's a problem there, right? Well, a challenge. The challenge is as you're creating all these machine learning models, they're going to grow and grow and grow. So the challenge there is model management. How do I manage all these different models and algorithms that are created? And that's actually a very, very serious problem for large enterprise companies is you're building all these models. You don't know what these models are doing. And by the way, these models are consuming storage, they're consuming compute, and they need to be maintained within a corporate environment, right? So what we're doing is with AIMS, we're allowing you visibility into all the algorithms that are running in your environment. Now, again, it doesn't, this is not really useful when you have 5 or 10 algorithms. This becomes really useful when you have 100, 1,000, 10 million algorithms running in a corporate environment. That's when it becomes very important. Why? Because it's going to cost you money to run all this. Corporate governance is also very important. Security. People that should be accessing the insights, you need to have some access control over. So what AIMS will also tell you is, well, who's consuming the insights from these algorithms? Now imagine if nobody was consuming from that algorithm. Well, what you're doing is you're wasting time and money by having this algorithm run in an environment that no one is using, right? You're using storage and compute, and you're throwing your money away to potentially, cloud vendors. So that's improving of that governance. And number 3 is, of course, reducing the cost. Model clutter is very important. We talked about model management. If you look about conventional model management tools out there, they can't do what this is proposing to do, right? At a high level. Think about GitHub. GitHub cannot do model management. It'll do model versioning, not model management. And this is an area that's really growing in the auto machine learning space, because what auto machine learning allows you to do is build all these great algorithms and automate that whole process. However, the consequence of that is you're going to have a lot of these machine learning models. And of course, the last part is controlling access control. Cybersecurity, and access control are really, really critical. So you want to secure your data. You want to encrypt your data. And by the way, this is all SSL TLS encrypted. And you want to make sure that people who are consuming are the right people to consume this data, because it's sensitive stuff. So all of this stuff is handled through AIMS.
Beautiful. So we certainly have dove pretty deep into what is a business domain, what is the domain of well drilling, deep well drilling. Certainly Clearblade as an IoT company sees the value of being able to get very specific and being able to reach these very specific models. We were excited today to be able to bring Audix here and work with Audix, a great partner of ours, for how we can accomplish not only what is an IoT activity, not only what is a visualization activity, not only what is an automation activity, but really begin to show in-depth, deep business knowledge of how we can take that data that we've got and make not what are hard and fast if-then rules, but really much high quality predictions based upon the historical information.
In real time.
In real time, at the edge, transactional machine learning, you got it. So that's what we had for today. We'll open it up for any questions that might be out there. I'm monitoring the questions field in the webinar. While we give you all a second to see if there's anything that might be interesting, I'll go ahead and mention that you certainly can reach out to us. Both of us, our websites obviously have submissions, but you can reach Clearblade at info@clearblade.com. Will come directly to us. Sebastian, is there a way that you can recommend folks might send you a question?
Info@audix.com, audix.ca, info@audix.ca.
Okay, so great. So we'll just take a few seconds. While we wait for questions, one question I often hear, especially in the oil and gas industry, is, how do you work with SCADA? IoT, how is SCADA integrated? SCADA is absolutely a data feed that we know how to work with. We understand that you guys are using different historians, different tools and technology for how you get out there. And Clearblade's real strength, if actually there was a a fantastic analyst article that came out that said, our strength in this industry, in the IoT industry, is our edge compute and our ability to work with what is the brownfield. So pulling off all of this data that might exist on the existing equipment. Again, we're not trying to replace that equipment. We want to get that data so we can do things like you saw here, which are help provide the data to AI models and databases such that we can make these great predictions. Sebastian, anything to add? We don't have any questions coming in right now.
Yeah, no, I think you hit on some really key points. And so let me just talk a little bit about transactional machine learning, which is exactly, fits really well with IoT. But you may ask, like, what is the difference between that and conventional machine learning? So as I mentioned, conventional machine learning models has a lot of dependency on humans. Transactional machine learning reduces those dependencies on humans in data preparation, model creation, model estimation, model reporting, and that's where transactional machine learning comes in. And of course, when you're dealing with data that's not static, i.e. the usual data that we deal with in conventional machine learning, but you're dealing with data that's streaming, that's continuously coming into your networks. That's where transactional machine learning really makes sense, because it really allows you to do machine learning on continuous data or continuous data streams, exactly what we're doing with Clearblade. And that's really the differentiating factor here. And that's where the value is. Think about Netflix, think about Facebook. Those are all data streams, right? LinkedIn, those are all streams that are coming in, message queues, etc. What we basically are doing is taking that analog and applying it to IoT data, right? And we're combining all that data together in real time, applying machine learning to it, and providing insights very quickly.
Great. Well, with that, we'll wrap up. We are going to make this available, so please do look for your email to see this recording available to you. We're certainly happy for you to ask and share it with your peers and those who might be interested. Really appreciate everyone joining me today. Thank you again, Sebastian, for taking the time with me. What a great session, and really enjoyed it. Thank you, everyone.
Thank you. Bye-bye.